Hello everyone, my name is Aaron Barth. I'm the head brewer at Big Storm Brewing, and today we will be talking about malting technology. So some of the things that we're going to talk about today are the types of grain that we use, how we evaluate the grain, and how we malt the grain. So these are the different types of grain that we use. Obviously barley being the main source of fermentable grain being used in the brewing process is malted, and after it is malted we either refer to it as malted barley or malt. Wheat is also commonly used in many different varieties. Each different variety can add a distinct flavor to the beer. Then we have things like corn, which is called sometimes maize. There's oat, which can add body to the beer. Rye, which can add a nice spicy dryness to the beer. And you have rice and sorghum. Rice and sorghum are usually used to make gluten-free beers. So when we talk about barley, we're talking about two different types of barley. You have 2-row and you have 6-row barley. As you can see from the picture here, the 2-row barley is a larger, more plump barley, and the 6-row is a smaller kernel. They get their name from a very obvious point that the 2-row barley has 2 kernels per row and the 6-row barley has 6 rows. Now, because the 2-row barley has more room to grow when it grows, it becomes larger. The 6-row barley is also commonly used. It's got high enzymatic properties to it, but these days with our malting technology, 2-row has plenty of enzymic property to it and is the more common used barley, especially in the United States. This is the basic structure of a kernel of barley. You have the outer husk, which is a waxy material which we use in the mash. You have the embryo. This is where we get a lot of the enzymatic activity from, which can also come from the allulose layer, which I'm sure is discussed in other modules. And then you have the starchy endosperm. The starchy endosperm is really what we're after here, because it's what contains all the sugars and all the material that we're going to use in the brewing process. Obviously, when we're talking 2-row versus 6-row, because 2-row's a larger kernel, it's obviously got a much larger starchy endosperm, which is something that is very beneficial for us in the brewing process. This is the composition of barley from North America, because things can change from season to season and from climate to climate and from growing region to growing region, even within the United States. And even this can change if you're in a single field. The moisture content and carbohydrate content of kernel to kernel will be different. This is just a general percentage of what the composition is of barley from North American barley. Moisture is usually between 10 and 14%. Carbohydrates are usually between 65 and 85%. And obviously that's the portion of the kernel that we're after. The inorganic matter between 2 and 4%, and the fat usually between 1 and 2%. Then of course there are other parts of the barley that are very small. It's usually around 1 to 2%. These parts of the barley are usually inconsequential to what we're using in the brewing process. So before we get the barley into the malt stir, it has to be evaluated. This is done because we have to have strict specifications for barley to be malted to be used for the brewing process, because enzymatic properties are so important to the brewing process. If the barley is not good, then the malt will not be good, and then it won't be good to use for brewing. Usually when we collect barley, there's a long spear-like device that's used. It's plunged into the rail car and pulled out, and it gives you a nice general overview of the type of barley that is in the rail car. If the barley is tested and does not meet specifications for malting, then it can be used for animal feed or food production. This can be an expensive proposition for the farmer because the varieties and the composition of the barley that needs to be used for brewing is specific enough to be higher cost. So if the farmer does not meet the specifications, you basically have very expensive animal feed or very expensive food barley. This is one of the reasons why malt is expensive and continues to rise in price. Valuation is done by spot and physical checks because when the rail cars come in, we have to very quickly evaluate the barley. The tests being used are not always very thorough, but they are good enough to determine whether or not the barley harvest will be accepted or not. So we will be going over the evaluations today that are quick spot checks that would be used for exception of a barley. Some of these spot evaluations are pretty simple. Things like smell. Pick up the grain, you smell it. If it smells clean, straw-like, if it's got a fresh smell to it, then that's a positive thing. If you smell any mold, mustiness, this could be a good indication that the barley will not be good for malting. If it was stored wet, if it was harvested wet, if basically it collected any extra moisture, then it could cause a bad malt to be produced as the end product. When the barley comes into the malt stir, it should feel dry and not slick to the touch at all. We want to make sure that it's light yellow and bright in color. We don't want to see any green. If you see green on the barley, that could be an indication that it was harvested too early. Gray, dull kernels could be rain damage. Brown tips could be due to either varietal or due to a wet harvesting. There are things like red corns, which could show signs of fusarium. Fusarium is a fungi that can develop in the grain. Fusarium can also be called vomitoxin for obvious reasons if it gets through to the finished product, which can happen if it's in the barley because it can't be boiled out. In the boil, it can cause people to become sick and vomit, therefore the name vomitoxin. While it doesn't happen very often, it is still something that we check for to make sure that it doesn't end up in the end product. Fusarium can also cause gushing, which gushing can happen for many reasons, but if it's also a sign of fusarium. Gushing is if you open a bottle or if you open a can, it foams wildly. Like I said, there can be many different causes of gushing, but fusarium is just one. The husk should be finely wrinkled, not cracked at all. If it's cracked and the husk is damaged, then the malting process could happen unevenly. Sprouting shows early germination. Obviously, germination is part of the malting process, and we want to control it. So if it happens early, then we're not controlling it, and we will get uneven or a non-uniform germination when we do go to germinate. We want low amounts of foreign bodies and damaged kernels. You will get things in the barley with it that is not just barley, but if it's in low amounts, it's okay. It happens. Higher amounts can be cause to reject a shipment of barley. We want high uniformity in the kernel, because if we are malting the grain, smaller grains will malt at a different rate than bigger grains, and if we're malting in a large volume, we want everything to happen at the same time. So we sieve out the kernels to make sure that the shipment of barley is around the same size. We want to see no infestation. Grain weevils can burrow holes into the grain. There are many insects that like to eat the grain, and obviously we do not want this in the finished product, so we take measures to make sure that the barley is not infested with any kind of grain weevil or any other type of insect. So like I said before, with uniformity, we want to do a sieve test on the grain. There are 3 different sieve sizes: 2.8 millimeters, 2.5 millimeters, and 2.2 millimeters. All the grain that gets caught on the 2.8 and the 2.5 millimeter are considered to be grade 1. If it gets caught on the 2.2 sieve, it's grade 2. And if it falls below the 2.2, then obviously it's too small to be graded, and can cause a harvest to be rejected. A batch is considered fine quality if grade 1 is at least 80% of the batch, and premium quality if it's 90% is grade 1. Even if a batch is fine quality or below, the grain can still be used for things like specialty malts, which will be discussed later. So once we've received the grain and it has met our specifications, then we are ready to start the malting process. The malting process consists of storage, cleaning, steeping, germination, and kilning. Sometimes you'll hear germination referred to as modification, but essentially the same thing. Modification usually ends up talking about the enzymatic process that happens during germination. So when the grain is accepted and stored, the barley has to be stored in a cool and dry climate. Because harvests happen once a year and malting happens throughout the year, we have to make sure that throughout the year of the malting process, the barley is still kept in a condition that is beneficial for malting. So cool, dry climates are our best. Hot, humid climates that we have here in Florida are not ideal for barley and malt storage. The barley needs to be cleaned before it gets stored. Like I said before, we have foreign objects in the barley that can happen during harvesting. You get rocks, dirt, the stalks from the separation of the barley, the kernel from the stalk can happen. Even foreign types of grain can be included in the sample. Then we need to steep the grain in water. This happens for about 48 hours at 52 to 64 degrees Fahrenheit. The barley will start to absorb some of the water, causing it to swell, especially in the starchy endosperm. This increases the size of the barley to a noticeable amount. Oxygenation is used to aerate during steeping, because during the steeping process, the grain will start to give off carbon dioxide, and carbon dioxide can inhibit the germination process. After steeping is done, we drain the water from the grain, and we either put it on a germination floor, that's a much older technique, or it's put in a barrel, a drum of some kind, to be rotated, because during germination you do want the malt to move around. Germination usually happens for 4 to 5 days at about 60 to 68 degrees Fahrenheit. During this process, the barley starts to modify, thereby the term modification. You see sprouting occur, which can also be called chitting. This is, like I said before, where the enzymatic process of the barley starts to happen, which you will learn about in another module. After the germination process, the grain is still very moist, which is not good for storage purposes. We also want to stop the germination process, because if we let the germination process continue, it will turn into a plant, because germination is just a process where the plant naturally starts to, the seed naturally starts to turn into a plant, and we want to stop this by heating. The grain is heated to 122 to 428 degrees Fahrenheit. This removes the moisture, thereby increases the stabilization for storage, and this is where we get flavor production. Now, if we're doing making a base malt or a base 2-row or base 6-row malt, we don't want an intense flavor from that. We want to keep as much of the enzymatic properties in that as possible. The higher the temperature, the lower the enzymatic properties. But on the other side, the higher the temperature, the higher the flavor. So higher temperatures create a more distinct flavor. You might see a chocolate malt, let's say, kilned at a much higher temperature, where a base 2-row is going to be closer to that 122 flavor, 122 degrees Fahrenheit. This is how we create our specialty malt. Things can also be done with the amount of moisture in the kiln. We can control the humidity and the moisture level in the kiln, which will create a different type of malt.